So relationship between what? Frequency then we have what? Wavelengths and what? Speed of radiation and speed of radiation. So I have to teach you how do frequency of the radiation relate to wavelengths and speed of radiation. So I say that the relationship between wavelengths, frequency, and the speed of radiation is given by wave equation. So what is that wave equation? Right? You learned during your Form 4. During your Form 4, if you do remember that, just recall. During your Form 4, we have taught you how to think in terms of wave by, first of all, having the formula, the fundamental formula, that we have velocity of the light, right? Velocity of the light is equal to what? So say velocity of the light or velocity of the wave, if you remember velocity of wave, this is the product of frequency, of wavelengths, and what? Frequency of the wave. So this is fundamental formula. I believe that you still remember. If you forgot, now I reminded you. So velocity. Okay? So the radiations, when you say radiations, because you have two types of wave. Okay? We have two types of wave. We have electromagnetic waves and non-electromagnetic waves. So you say that for electromagnetic radiation, we say that the speed of the light. So we say that the speed of the light is emitted by C. And its magnitude, and we say that C is equal to the speed of radiation, so speed of light, which is 3 exponent 8, right? And then meter per second. So in chemistry, whether in chemistry or in physics, we represent wavelengths not by using V. We represent the velocity of the wave not by using V, but represent the velocity of the wave by using okay. So if that's the case now from this formula, where we say that the velocity of 40 of the wave, which is C, is equal to wavelength times frequency. Right? So the speed of the light is constant, always. So in most cases, we may make a frequency the subject, so you get the speed of the light over wavelength. Right? or possibly that wavelengths are being shifting from there, right? However, it is a little bit challenging. So say wavelengths, this will be the speed of the light over frequency. So these are the two relationships that are very important. That the frequency is equal to the speed of the light over wavelengths, and then she said the wavelength is equal to speed of the light over frequency. So this is the secondary relationship. So you have to bear these two relationships between those terminologies or terms of 40, or used denoting hydrogen spectrum. Again, we have another term that we call the wave number. We can also have its mathematical formula, and this wave number, the term's wave number, we say that this is given as this symbol, right? So we say that the wave number is the wave number. This is a reciprocal of what? Reciprocal of wavelengths, right? So it's a reciprocal 40 of wavelengths. So wave number is a reciprocal of wavelengths. So for example, from equation 1, in position, so I say from equation 1, for instance, frequency is equal to what? Speed of the light over wavelength. So this is equal to speed of the light, and then wave 1 over what? Wavelengths. Right? So that is 40, that is the meaning of 40 of frequency. So in this meanings of frequency, you say that, for example, you say also frequency, it will be equal to what? Frequency is equal to the speed of the light times wave number. So if you've been looking at the wave number, you can take what frequency over speed of the light. So this is the formula for finding what? For finding wave number. But also you can have even the fundamental, that wavelengths are that the wave number is equal to this one. So this is also important formula. Right? And those equation 1, equation 2 are very important. Even this one is very important. So we can express the wave number in terms of wavelengths, in terms of frequency. So remember that here, we say that C means that the speed of the light is what? So we say the speed of the light is constant. Right? Speed of the light is what? Is constant. So because the speed of the light is constant, then it is known. So even if that you won't be given for the matter of computation, we can also recall. Again, so frequency and wavelengths are variable. So frequency and wavelengths are variables. So well, so if that's the case now, let me do one example on computing or calculating those terms. Then I will leave you for some time, or it means that it will be the end of this session. I'll join me in the next session to enjoy the beauty of 40 of the chemistry. So I have a question here. So this is the example. So this is the example for instance. Or let's say that's 7, 8, so I think this is the example 7, if I'm not mistaken. Most of the light from the sodium vapor in the sodium vapor, most of the light from the sodium vapor, lamp is wavelength. Lamp has what? Has a wavelength. Vapor lamp has a wavelength of 40 of 589 nanometer. Wow. Nanometer. What is Roman 1 or Roman R, just to avoid confusion? Roman 1, what is frequency? What is frequency? What is its frequency? What is frequency? F. Then B, we say that the wave number of the radiation, wave number of radiation so speed of the light, the big given that the speed of the light is 2.998 2.998 exponent 8 meter per second. So then you have that fantastically simple question. We say that most of the light from the sodium vapor lamp, so it's just like a lamp, like a normal bulb or whatever, but it's sodium, it contains sodium within it, a formulating vapor, has a wavelength of this. What is frequency wave number of radiations when the speed of the light is that one? Chemistry is beautiful. Do you enjoy it? So, solution. So we say that we will be given wavelengths, so that we'll be following some steps on solving this problem. The first one, let us obtain the data given in the question. Okay? First piece of information is this. Wavelengths . 589 nanometer. And if you convert this slightly, so we say the wavelength will be 589, so -9 meter. So bear this. It doesn't mean that the wavelength is always this far, no. I just took the distance in nanometer, then change it into it. So remember the unit you'll be using in your computation, right? Whether in this concept or in the further concept. The unit that might be used, it means depends to the what are you dealing with. Small unit or large unit. So that's why I said that wavelength is equal to that one. So again, the question asks us frequency, and the given the speed of the light. So the second step, so we have to record the formula, but the main thing we have to compute. Okay, we have to compute. So to compute what? Compute the frequency. With the frequency. So then, so is that the case? You say that C is equal to wavelength times the speed of the light is equal to wavelength times what? Frequency, right? So we given sorting, we given wavelengths, and then you have to compute the frequency. So compute the frequency for this case, it will be C over wavelengths. Right? So this one is our frequency is equal to 3 exponent 8 meter per second over wavelengths, which is 589 actually negative 9 meter. So that is the steps of the formation that we need to go through. Now you can take your scientific calculator and then you do your computation. So there it is, what 3 exponent 8 so then divided by 589 actually negative 9. So the frequency, it is 509, so raise, so it will be 3 hertz, right? Hertz. So therefore, what I've been asking the question, what the frequency of sodium, of light, so therefore the frequency so he said the frequency of light of the light is this is 5.0993 exponent 4, excuse me, exponent 14, not exponent 4, exponent 14 hertz. So this is the higher frequency compared to the specimen. So this one said the frequency of light is what? 5.093 exponent what? Okay, so this one is printed 14, and then so it is. So that the response to 40 of that question, the frequency of the light from the sodium vapor is issued. So if that's the case, before I end these sessions, I would like just to leave a homework for you. This will be homework 4. Courses from the session 4, and then so when we'll be ending this lecture, you can watch also the next lecture, which we are taking you deeper and deeper about the concept of sequences and logging series. So this will be example. So example. There we had example 7, right? So this will be example 8. Example 8. So example 8 but this is homework. You have to make sure to go through the contents and then to try to answer that homework question. But that was the part A. So thank you very much, Holy Spirit. That was the part A. Part B, so say the wave number, this is simply what? The reciprocal of wavelength. So you just take one of what? The given wavelength, which is what? 589 exponent negative 9. So if you compute the wave number before this example question, which is the homework, if you compute your wave number, for that case, so say wave number. So say wave number for this case, so wave number, we say that this will be equal to 1.6 exponent 60 per meter. So therefore, wave number is 1.6. After using your scientific calculator, 978, 98, exponent 14. At 14 or exponent 6. Exponent 6 because it is reciprocal of wavelength, so it is, the unit is per meter. So to write the right response, you say that the wave number, or the total number of oscillation, the wave number is 1.698 exponent 6 per meter. So that's the response for that question. So now it's time for the homework. If you have any question, don't hesitate yourself to ask in the comment section. Homework, and this is homework 4. Then this is the question that you have. The frequency of the light spectrum, of the light from sodium vapor, okay, the frequency from sodium vapor is from sodium from what is from sodium from sodium vapor, from sodium vapor. So from sodium vapor is 5.2, so it's 14 per second, or hertz. What is what is one wave number so wave number is, so what is wave number? So find the wave number 40 of the wave. And we go from 1, 2. We say that find the wavelengths of the wavelengths of 40 of light. And how does wavelengths and F relate? Wavelengths of 40 of the light. Again, we have to explain briefly about what TB, Roman 3, and the explanation that you have to present. How does frequency and wavelengths of light of 40 of light and what? And frequency. So the wavelengths of the light and the frequency of light. To explain the Roman theory, you have to show how do they relate. Are they very proportional? What the relationship between wavelengths and what and frequency of the light wave? Is there any relationship? Is there any? Yes, so that's what I asked you. So make sure that you do the homework, submit your homework. This is a serious program. Submit your homework on comment section for review, comment section. Right? So if that's the case now, I would like us to say that the end of session 3, part A, we'll meet against, part A may possibly A and B, we'll meet against in the session 4, because we didn't finish it yet, so we can cover some other concepts. Thank you very much. I thank God, first of all, who have been with me, and who have been giving me power, strength, creativity to teach you all about advanced chemistry. And the topic is general chemistry, and the concept is all about the hydrogen spectrum, right? So that's a great thing that you have to make sure that you know. So make sure that you go through the contents and you share. As I told you, you subscribe if you didn't remember for subscribe. When the video is posted, you can do all other activities. So thank you very much. May God bless you. And then I would like to meet you in the next session of either advanced chemistry or other subject. So may God bless you and have a nice moment. Thank you very much. This is Olenjolai Marco. See you in the next lecture.